Good morning. Wow, that's a lot. Won't put my head down. All right. Try that. Is that all right? Sounds a little tinny, but. All right, good morning. My name is Ricky Mclain. I have the distinct pleasure of being both a moderator and a speaker in this session, but I appreciate you choosing to sit in on this. Hopefully you find it very beneficial. I'm going to explain Woodworks, the organization that I'm with, in just a second here, and then after I talk about what is mass timber, and in particular its relevance to the Northeast here, Jillian Tomaselli with Stevens & Associates will also be speaking. I may not even need this. And then Paul Frederick from Vermont Forest Parks and Rec will also be giving a presentation about species grown here native in the state and how we can potentially use those in mass timber construction. To start out with, just one housekeeping note. On the back table there, I do have some literature about some of the things we'll be talking about. There's also a sign-in sheet. If anybody here does need continuing education credits, please just fill out that sheet and we'll send you a certificate. And feel free to grab any of the publications there. So I am with an organization called Woodworks. We're a national nonprofit organization. I do live here in the state. I live in Cabot, so it's just about a 40-minute drive for me today. But Woodworks does have a national presence. We're about 30 people total, and everybody works remotely. So I work out of my house in Cabot, and we're spread all throughout the country. So it's been a pleasure. I've been working with Christine over the past 18 months or so on what we call a Vermont Mass Timber Action Team. And the next thing, Jillian's presentation you'll hear is one of the outputs of that Mass Timber Action Team, which is a feasibility study on a project down in Brattleboro. We're able to do what we do for free because of the support of our funding partners, primarily the Softwood Lumber Board. Craig mentioned them in his talk last night. And if anybody's not familiar, it's part of a checkoff program where softwood lumber manufacturers pay essentially a self-imposed tax. That tax gets pooled together, and we're the largest recipient of the Softwood Lumber Board. They fund about 55% of our program. And what they're paying us to do is essentially be experts in the technical side of wood construction. So we help architects, engineers, developers, building owners, anybody that is potentially interested in using wood in construction. We help them get beyond just the stage of, yeah, this mass timber stuff's really cool. We help them actually put pen on paper. So questions on fire ratings, acoustics, construction types, span capabilities, connecting them with manufacturers. That's the role that we play. I'm a structural engineer. We have a team of structural engineers and architects and other construction industry professionals. We also have received some funding from USDA Forest Service and Forest Renovation Investment. So this is really what we're trying to do, is to grow the demand side, the interest in wood construction. Mass timber is certainly a big aspect of that, but we also help on essentially any wood frame project. So your typical 2x6 wall construction, I-joist, trusses, everything from that up to mass timber. So we really do that in two realms. Number one is that free project assistance that I mentioned. So if you come across anybody that's potentially interested in designing a wood building, feel free to have them reach out and contact us. We can assist them on any questions they have for free. And then the other thing that we do is education. We try to provide a large volume of educational events every year. In 2018, we're hosting over 250 of our own branded events, in addition to events such as this where we participate in as speakers. So we're, as you can see, spread throughout the country. Our next largest event in this area is in Boston in September. That's going to be an all-day mass timber design symposium. So these are the mandatory AIA slides. We'll skip right through to the presentation. Over the next 25 minutes or so, I'm going to try to cover these four topics, those being basically an introduction to what is mass timber. Just out of curiosity, who here has heard of or is somewhat familiar with mass timber? So about a little less than half the people. Okay, so that's good. So this next session will hopefully give you an introduction to what is mass timber, both the systems and the products that go into a mass timber building. Then we'll also take a look specifically here in the Northeast, what's going on with mass timber construction, and then finally take a look at what do we see as coming down the road next with mass timber construction. So when I think of mass timber, I think there's a distinction in my mind, but a similarity between what I'll call mass timber construction and heavy timber construction. So heavy timber construction, probably most of you are familiar with, the photograph on the far left here. If you go back in any old building, more than 100 years old. And post and beam style construction, it was probably using what I would call heavy timber. So that's where, you know, they have solid timber columns that are maybe 10 by 10, 8 by 8, but those were cut from one single log, right? What mass timber construction does is it allows us to create those similar sized large cross sections of wood, but instead of cut from one log, it could be 8, you know, individual 2 by 10s that were glued together or something like that. So that's, you know, historically where timber construction has been. Now, usually where, unless it's kind of the specialized timber frame, now where wood construction more has moved into is this realm of light frame wood construction. And that could be everything from single family homes up to, you know, 4 or 5 story apartment buildings, hotels, etc. What mass timber construction has allowed the construction industry to do is to really bridge the gap between those two. Now we can go back to the historic post and beam style construction, still using wood, but it's using mass timber. So again, it's panelized systems like this, where these are glue laminated timber beams that you see here. On top of that is a nail laminated timber floor deck. So creating solid timber sections, panels, slabs essentially, that are completely timber construction. So real briefly, I'm just going to go into an introduction of really, I guess, the 4 common styles of framing a mass timber building, and then we'll look at the specific products that go into that. So the first, by far the most common style of modern mass timber framing is post and beam style construction. And this is a great example of that. This is called the T3 building. It's in Minneapolis, Minnesota. It's a 7-story office building, spec office building. Amazon has office space in this building. It's 1 story of concrete and then 6 stories of timber construction, like you see this style of framing here. So this is glue laminated timber columns, glue laminated timber beams, and then on top of that is a nail laminated timber deck, which I'll explain all of those products in just a second. The second option, certainly less common, but we're seeing much more interest in this style, is what's called two-way panel systems, two-way span systems. So this style of construction is used sometimes in concrete construction, and the idea here is that if you look down really this aisle of columns here, you see there's no beams. There's not a single beam on this entire project. All of these timber slabs or timber floor systems are point supported just at the column locations. So that timber floor is actually spanning in both directions, as opposed to the previous system we had where there was beam, 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 and the slab was just spanning one direction from one beam to the next. The third option is really mixing kind of a hybrid approach using light frame wood construction and mass timber construction. This is a project up in British Columbia where it from the outside kind of looks like a traditional 4 or 5 story light frame apartment building. But what they've done here is they're still keeping those 2 by 6 vertical stud walls, but instead of a floor system and a roof system that's either trusses or I-joists, here they're using cross-laminated timber floor panels. So they get the aesthetic from below, they're exposing that timber panel from below. They're also getting the benefit of speed of construction that cross-laminated timber can allow. But the vertical systems are just as you would see in any other type of light frame wood project. And then the fourth style framing, sometimes this is referred to as the honeycomb style of framing, where it's basically mass timber bearing walls and mass timber horizontal surfaces. This is a 4-story hotel in Alabama. This is all cross-laminated timber construction. So you can see this is looking down kind of the corridor of what will eventually be this hotel. Bearing walls separating up each of these individual hotel rooms, and then they're lowering this section of cross-laminated timber floor panel that will be essentially the walking surface over this corridor. So that's the kind of the snapshot of the 4 styles or the 4 ways that you can kind of frame the skeleton of a mass timber building. So what are the actual products that go into that building? The first one, I've alluded to this a few times, glue laminated timber, often called glue lam. It's a product that's been used in construction for almost 100 years here in the U.S. Very common in especially timber bridges, but it's seeing more of a renaissance as this mass timber revolution occurs in the U.S., starting to see more of a renaissance here. Simplistically, it's using mostly just 2x commodity lumber, and you place one on top of the next flatwise, a screen of adhesive between each. The entire section is pressed together and planed. So you end up, again, with this solid cross-section of wood that could be 8 inches wide, 2 feet deep, but it's made up of a number of small individual laminations of wood. One of the benefits with that is that you can vary the strengths of the laminations of wood based on where the structural stresses are highest. So if you think about a beam that's in bending, the top of that beam is in compression, the bottom's in tension, so you can place your higher strength laminations there and then potentially use a lower grade lumber in between. So you're really optimizing, whereas the solid 10 by 14 beam, it was the same strength properties throughout. This style of post and beam construction with glue lam, oftentimes we're looking at projects like this, but I did want to highlight that there is capability to use glue lam in much larger, flexible shape sizes of buildings. This is the Buffalo Sabres practice facility in Buffalo, New York, and you can see that the roof construction here is mostly glue laminated timber. There are arches that are spanning across the entire hockey arena, and then the actual bottom core there is a structural steel shape. I don't know if I have a laser pointer here. Yeah, so the bottom here is structural steel shape, and then the top are glue lam arches. And then the actual products that go into the horizontal surfaces. So if we've essentially thought of creating this structural skeleton of a building with beams and columns, now we need obviously those horizontal surfaces, the floor surface and the roof surface. So you can see there's a pretty wide variety of products that we can use to frame those systems. We're going to focus mostly on the top three. Those are the most common. I do have samples of cross-laminated timber and nail-laminated timber on the back table too. I meant to bring them up and pass them around, but feel free to put your hands on them and kind of see what they feel like. So the first one, nail-laminated timber. And again, you can see the common theme here. Most of these products are just made up of a number of individual smaller commodity lumber products. This is simply taking 2x lumber, 2x4, 2x6, 2x8, each orientation on edge, and then just nailing one lamination to the adjacent lamination to form a solid timber panel. Usually this is something that's fabricated off-site, so you might have an off-site warehouse or fabrication facility, and a contractor or framer would be fabricating panels maybe in 8-foot widths, 20 to 40 feet long, and then those panels are erected on site. And essentially you can think of that as very similar if you're familiar with precast concrete construction, where they're casting these slabs off site, just bringing them to the site and erecting them, very similar with nail laminated timber. Also, there is a copy, if anybody is doing any type of mass timber building design, there's a copy of this on the back table there. Feel free to grab it. It's a great resource, nail laminated timber design and construction guide. You can also download this free on the web. Just one example of a modern timber project that has used nail laminated timber. This is the Bullitt Center. It's a spec office building, it's a custom office building in Seattle, Washington. This was completed about 6 years ago, and you can see just looking down this open office space, really beautiful structure. Glue laminated timber columns and beams, and then nail laminated timber for this floor surface and roof surface. So that's exposed from below. It's usually not exposed from above. Typically on top of this surface, you'll have, first of all, some type of an acoustical mat, because acoustics is a concern in these types of structures. And then oftentimes you're pouring either a thin concrete topping layer or using a combination of other materials on top that eventually your floor finish is installed on, and then those also help with acoustics. So the underside can be exposed, but the top is typically not. Dowel laminated timber, very similar to nail laminated timber in terms of how it looks and how it goes together. The difference is that rather than using nails to attach one lamination to the next, we're using hardwood dowels, where you're basically drilling through the entire panel and then inserting these hardwood dowels through to just tie that panel together. And then glue laminated timber. We talked about glue lam in terms of a beam and column application, but some people are actually using this to form solid timber panel surfaces, where you're basically just fabricating, usually they're 2-foot deep glue lams, but then you just lay them on their side and then lay multiples of those beams side by side. If you can see here, I'll try to point it out on this one. The laser's not really going to show up, but you can kind of see profile lines about every 2 feet in that floor surface or ceiling surface on the project on the left, and those are just 2-foot wide glue lam beams that were fabricated to form that floor surface. And then more of the traditional heavy timber construction is using tongue and groove decking. Everybody's probably familiar with this, 2x, 3x, or 4x are the most common. One example of a very recent project here in the Northeast that used this approach, this is the Patrons Oxford Insurance Building. It's this insurance company's headquarters in Portland, Maine. This was completed just about a year ago. Two-story structure, about 20,000 square feet, and they used, as you can see here, exposed timber, blue lam beams and columns, and then tongue and groove decking system on top of that. And then probably what's, some people consider the rock star of the modern mass timber movement is cross-laminated timber. So what is cross-laminated timber? It's a solid panelized timber system, and again, it's made up typically of 2x commodity lumber products. But the difference between this and nail lam or dowel lam is that instead of each lamination being oriented vertically, each lamination is flat. So you basically lay one lamination side by side to the next. Maybe you do that so you have an 8-foot wide strip of 2x's, screen of adhesive over that entire surface, and then another lamination of 2x's goes on top, but 90 degrees, perpendicular to that previous layer. So you keep doing that alternating directions. You generally have an odd number of plies so that the two face plies are going the same direction. It's very similar if you think of how plywood is made. You have that same style of alternating directions. People have referred to CLT as plywood on steroids, right? Instead of a 1/2-inch thick panel that's 4 feet by 8 feet, you have a 7-inch thick panel that's 8 feet by 60 feet. So those are the dimensional differences we're talking about. So just kind of to look at the end or cross section of a panel of CLT, this is what we're talking about. Just to give you some idea of scale, a 3-ply panel is about 4 1/8 inches thick. 5-ply panel is about 6 7/8 inches thick, and a 7-ply panel is about 9 5/8 inches thick. Those are the three most common thicknesses in North America. Once you get above that, it starts to cost become an issue there. So. One of the differences, too, in terms of how we think about timber construction and modern mass timber construction is that it's a completely prefabricated style of framing. You're not going to your local lumber yard, purchasing, a stockpile of CLT panels, having them delivered to the site, and then you're cutting each one to size. You're figuring out where on the project each panel goes. This is completely done through a shop drawing process, generally speaking, a 3D building model process, where every panel, every product is for a specific location, cut to size, even things like notches, holes, window and door openings. Everything is done prior to getting to the job site. Even how these panels are loaded sequentially on the truck is thought out ahead of time, so that when that truck arrives, it's pick and place, right? You're not having to create a separate material stockpile on site. So it's a very quick installation process because of this pre-planning work that goes into it. Just an example of a project, we saw this one previously. This is the 4-story hotel called on a military base called Redstone Arsenal. Just as a point of local interest, this developer called Lend-Lease has actually since constructed a second one of these 4-story COT hotels at Fort Drum in upstate New York. So starting to see more of these locally. But one of the interesting stories with this project is that this developer has a contract with the Army to develop over 50 of these hotels. And they've traditionally always built them on military bases. They've traditionally always built them with light gauge steel stud framing. That first project, this one you see here, this company does international work, and they had used CLT in some of their international projects. They decided to give it a try in the U.S., and what they found was that because of the speed of construction, they were able to frame this about 30% faster than their traditional light gauge steel projects, using almost about half of the number of people on site to frame it. So they had a significant reduction in on-site workforce, while at the same time shaving about 4 months off the construction schedule. So because of the success of that project, they're now moving forward with the Fort Drum project I mentioned. They're also working on, I believe, 1 or 2 of these CLT hotels in the Pacific Northwest, as well as one in South Carolina next year. The history timeline of CLT is interesting. It's very short, as you can see here. Really started out about 30 years ago now in Austria. It was actually part of a research grant project at a university level. But in North America, we really didn't start to see any type of use or interest until about the year 2006, 2007 was the first U.S. CLT project. But as you can see here in this very compressed timeline, things have progressed very quickly. One of the big areas that we assist designers in is understanding the building code, and the 2015 International Building Code was the first time that CLT was recognized as a building material, which was a huge hurdle. Basically what it means is that each project that wants to use CLT doesn't have to go through a unique variance process. It's in the building code, so therefore they can use it. We'll get into at the very end here in just a couple minutes when we start looking at kind of the next step. There's more interest in tall wood buildings, and the code is continually evolving to recognize that. International Building Code comes out a new version every 3 years. So right now the most current version is the 2018, but the changes for the 2021 Building Code are already in process. So I did mention the significance of CLT being in the 2015 Building Code and all versions since then. And then one great resource to point people to is the Cross-Laminated Timber Handbook. This came out in 2013 and was really the first design publication to help people that are interested in designing buildings with cross-laminated timber. And you can download this for free on the web as well. So another question that we get very often is, all right, I'm kind of interested in this mass timber thing, and again, we help engineers and architects all around the country. So is there anybody near me that's producing mass timber, in particular CLT? Glulam suppliers are fairly abundant, spread throughout most of the states. Regionally, the closest, largest one to us is in Unadilla, New York, a company called Unilam. So these are the current certified CLT manufacturers in North America. You notice there's currently only 4 of them. When I say certified, what I mean is that they're producing CLT products that are certified according to the production standard that the building code requires. So that means they've gone through a certain process of structural testing for their products. They meet certain fire requirements and certain manufacturing standards. So the closest one to us regionally is in Canada, an organization called Nordique. There's also one in Western Canada, Structurlam, and then the 2 in the US, one in Oregon called DR Johnson, and then one in Montana, Smartlam. There are several others in Eastern Canada, closer to us, that you see here that are currently producing CLT. However, they're not certified according to that production standard. But really, there's a lot of change. As we noticed that short timeline for CLT in general, there's also a lot of change happening in terms of manufacturers. In February, within the same week, 2 manufacturers announced plans to open CLT production facilities in the state of Maine. In addition to that, there's a CLT production facility under construction and very close to completion in Alabama right now. There's another under construction in Spokane, Washington, plans for others in the Pacific Northwest and potentially in the Southeast. So as you can see here, the map is essentially starting to fill out, and because of that, there's going to be greater availability of cross-laminated timber, hopefully within the next couple of years. And in addition to that, there's even some organizations that are importing CLT from Europe. My hope is that as more manufacturers come on in the U.S., in North America, we'll start to see less of that and more use of our locally sourced CLT here. Specifically looking at the Northeast, I've shown a few projects, in Alabama. There's quite a few in Portland, Oregon area, Pacific Northwest. But is this actually happening in the Northeast, where we are here? It is. It definitely is. And I would say my personal perspective on this, as far as the number of questions that we get regionally, I would say the most interest in mass timber right now is in the Pacific Northwest, the Portland, Seattle area. Second, though, is the Northeast. We're seeing a ton of interest for mass timber in Massachusetts, in Maine, in Vermont, and New Hampshire. So there's a lot of interest here, and hopefully these several example projects illustrate that it is being used. This is about a 15,000 square foot school in New Haven, Connecticut, called Common Ground High School. Mass timber, several different types of mass timber products, including cross-laminated timber, were used in this school facility. In upstate New York, this is actually the fabrication shop for a timber framing company called New Energy Works. This is the first all CLT building in the state of New York. It's about 20,000 square feet, and you can see they're using CLT for both the wall panels and the roof panels, and then glulam columns and beams. And then really the game changer as far as significance of the size of project and display of the use of innovative mass timber products. This is a 4-story building at the University of Massachusetts Amherst called the Design Building. This opened in early 2017, so it's been open for about 18 months now. And it's really a unique and excellent display of the variety of mass timber products and systems that can go into construction. There's lab space, classroom space, and then there's also this really beautiful entry courtyard, interior courtyard area. On top of this, you can see there's skylights. There's actually a green roof area. One of the departments that this building houses is landscape architecture. So they're using this building not only as housing for their classroom spaces, but they're using the building itself as a teaching tool by exposing the structure, exposing the mechanical systems, using that green roof. So just some of the images of that project. And then here in the state of Vermont, there's an interesting story behind this. This is actually under construction now. It's the new base lodge from Mount Snow in Westover. I gave a mass timber presentation at an event probably about 18 months ago. And after that event, one of the architects who attended that contacted me about probably 2 months afterwards, saying, hey, I've got this new base lodge project I'm working on. It was planned to be all steel construction. And he's like, I really liked the presentation, interested in using mass timber. So throughout the next month or so, I helped him work through a lot of the design questions, construction types, fire ratings. Ultimately, what happened with this project is that the roof is now going to be exposed glulam. They didn't end up using CLT. They actually just are using a tongue and groove decking system. But I saw some photographs. A lot of that timber has been installed, and the project's looking really beautiful. So just a local example of a great use of mass timber construction. And then in closing here with just the next few minutes, I wanted to give a glimpse into kind of what do we see coming up next with mass timber construction. I say the future's looking up. There's a lot of interest in going taller, building taller wood buildings. What's interesting now, and I mentioned the building code and the fact that it updates every 3 years, up to the 2018 International Building Code, currently wood buildings, whether they're built with 2x6 studs and I-joists or whether they're built with cross-laminated timber or glulam, they both have basically the same allowable height, which is either 5 or 6 stories, 5 stories for residential occupancies, 6 stories for offices. So there's no current recognition of the difference in terms of the structural capabilities, the fire capabilities of something like mass timber. Well, some examples of projects that have started to go into this taller wood realm. This is the T3 project that I mentioned previously. It's 7 stories. This one actually does fit under the code's current prescriptive allowances. The reason for that is because that first story is concrete. And then there's 6 stories of timber construction on top of that. But a few projects have exceeded the code's prescriptive allowances. The first one here is called Carbon 12. This is an 8-story condo project in Portland, Oregon. This is all mass timber construction with the exception of there's a structural steel braced frame, very high seismic loads in the Portland area. But this is all mass timber construction aside from that. And I believe this building is it's finished and about half of the units are sold at this point. And then the big one is the 12-story framework project, which is scheduled to begin construction hopefully this year. This was the winner. In 2015, USDA had what they called a tall wood building competition. And they were soliciting design teams to submit wood designs for buildings that would be taller than 100 feet. So this was the winner of that design competition, received $1.5 million of funding from Softwood Lumber Board, USDA, several other organizations to fund the research and the additional design work required to go into actually seeing a 12-story mass timber building to fruition. So this building has received all of its required building permits, and it's going to hopefully start construction soon. On the building code side of things, in terms of looking at tall mass timber buildings, the code did recognize this trend in interest in taller wood buildings. So in 2015, the International Code Council, which is the body that writes the International Building Code, started what they called an ad hoc committee on tall wood buildings. And they tasked this committee they wanted them to come up with a set of code change proposals that the committee and voting governors would vote on eventually to allow taller wood buildings prescriptively in the building code. So throughout the next 2.5 years or so, this tall wood committee required things like complete compartment fire testing, like you see on the left. This committee was composed of people from the wood industry, but it was also composed of people from steel, concrete, fire service. Ultimately, what they did was, the deadline for their submission was January of this year, so about 6 months ago. They submitted what their proposals were to change the building code to allow taller wood buildings. And so the proposal included basically 3 different variations in tall wood buildings, the tallest allowing up to 18 stories of mass timber construction. The next step was in April of this year, so just about 2 months ago, the first round of committee hearings took place, and the short story is that there was great support for these tallwood code change proposals. The committee votes on this. It's a 14-member committee, and they basically vote, is that going to be recommended for approval or recommended for denial? All 14 submissions were recommended for approval, and with the exception of one, all were recommended unanimously for approval. And then the one that wasn't unanimous, it was 13 for and 1 against. So nearly unanimous suggestion for approval by the committee for these tallwood code changes. So the next step is October, November of this year, the vote actually takes place. So these are people that have ICC memberships, so typically building officials, plan reviewers, people in governmental positions will vote on these code change proposals. And if they're successful in the vote, starting with the 2021 building code, tallwood buildings would be prescriptively allowed, which would be a great step forward for expanded use of mass timber. And then in closing, what does that mean here in Vermont? I realize that Vermont is not going, I live in the state, I realize we're not going to see 18-story mass timber buildings, right? So what does that actually mean for the state? Well, I think it can mean a couple of things. Number one, I think there's much concern about, especially the young labor force, and creating interest in jobs more on the technological side of timber construction. Right, as we see more of this modern mass timber construction taking place, there's more jobs, around things like computer numeric control machines, creating 3D building models. It's a kind of a shift in the technology side of timber construction. And of course, ultimately, what we're trying to do is grow the labor force and grow a market for continued use of forest products. So just some of the statistics here are interesting. Over 700,000 jobs, direct and indirect jobs, currently exist because of the harvesting and manufacturing of softwood lumber products. And one of our primary roles is to see that number increase and also see the use of locally harvested forest products increase. And one of those venues could be through the use of mass timber construction in buildings. So that's all I have. We will take questions, I think, at the end, just to allow our other speakers some time. So please hold your questions till the end. And with that, I will introduce our next speaker, which is Jillian Tomaselli of Stevens & Associates. You can try this if you want, but it was kind of acting up on me. I think that also might work if you want to try that. Table? All right, I guess we have to use a table one.
All right, well, I'm going to start, and can everybody hear me if I just speak loudly enough? Yeah, pretty much. Okay, so hi, my name is Jillian Tomaselli, and like Ricky said, I'm an architect with Stevens & Associates. We are an integrated architecture, structural engineering, and civil engineering firm down in Brattleboro, Vermont, so about 2 hours south of here. For about the past 6 months or so, we've been collaborating with Woodworks and the Vermont Sustainable Jobs Fund on a mass timber comparison study. And I'm going to go into more details soon, but essentially this study was to take a project that we had in our office that was designed using concrete and steel and regular, your typical light frame wood construction, and then redesign it with mass timber so that we could compare the cost and design implications and see what that would look like here in Vermont. So today I'm going to walk you through the process and the construction assemblies that we came up with and the results that we found at the end of the study. So the design team, Stevens & Associates was the design team for this project, and then we had the help of a great advisory committee, and the people involved in this committee, there were about 12 of us, I think, packed our conference room a little tight, but it was great because they came from a lot of different backgrounds, including construction, economic development, engineering, housing. So it was really great to have all of those different voices in the room. And I've listed the major participants here. So the purpose of this study was to explore the role of Vermont in the mass timber industry and to understand if there are opportunities for the industry to utilize locally grown wood. So in other words, essentially, there's two different goals. We wanted to see if it made sense to build with mass timber around here, and also to see if this region could have a role in the supply chain and what that would mean. Our approach was first to identify what I'm calling a benchmark project, and then to adapt that project to incorporate mass timber, and then to use that to compare and evaluate the design requirements and the schedule and the cost implications. So our main criteria for choosing the benchmark project was that we wanted it to be something fairly typical for Vermont, something that was a common building type, size, program, and something that the lessons that we learned from this project could be used again and repeated. So we didn't want to choose a project that would be sort of a one-off showcase project. And then once we chose that benchmark project, reviewed the building codes, the energy concerns, acoustic requirements, structural requirements, best practices, and then with the help of our advisory committee, adapted our design to mass timber. And the goal was to basically change the structure from steel and concrete to mass timber, and then only change other components of the design as necessary to use mass timber, and to keep as close to it as apples to apples comparison as possible. We didn't change the brick masonry veneer on the outside. We didn't change the finished floor, only the things that had to do with the structure. And then once we had an understanding of all those requirements, we sent it to a cost estimator, got those results back, and compared them. So the slide is what is mass timber, but Ricky has already gone over this. So we, the advisory committee, we considered everything that he talked about. We looked at glulam, CLT, NLT, DLT, and tried to choose what was the best system for this project. So this is a short description of the benchmark project that we chose. It was called 29 Flat Street, which has since been renamed the Snow Block. So if I slip up, it's still in the design process. So 29 Flat Street is a project that came to Stevens & Associates about last summer. We're designing it for the Wyndham and Windsor Housing Trust, and we completed the conceptual design last fall. And that was the set of drawings and the level of design that we were comparing, or that we adapted to the mass timber design. The project is located right in downtown Brattleboro. It's a mixed-use, multifamily building and commercial building. It's got rental space on the first floor, and then 23 residential apartments above. It's about 60 feet tall, 5 stories, and then 21,000 square feet. The site was a special constraint because it's 60 feet wide, only 60 feet wide, and our building is 60 feet wide. And because it's downtown, we have what's called a zero lot line condition on both the east and the west. So we're built right up against the building on the east, and there happens to be a vacant lot to the west that you can see here. We also had special energy requirements. The Housing Trust they want to meet Passive House certification with this project. So when we went through the original design process for the benchmark project, our conceptual design, we made certain assumptions regarding the R value of the wall and the insulation in anticipation of that. So you're going to see that both our benchmark design and the mass timber adaptation have a double stud wall, and it was for the purpose of, again, the apples to apples. It was in the benchmark, so we wanted to keep it in the mass timber design. This is an image of the project from Flat Street. You can see the empty lot to the west, but besides that, it's in a pretty dense area in downtown Brattleboro. This is the first floor plan. We've got a common room and commercial space out on Flat Street, and then tenant amenities in the back. The second and third floor plans, which are both the same, have a double loaded corridor with apartments facing front and back, or south and north. And again, this was because of that zero lot line condition, so we don't want windows on either the east or west side. It's a mix of efficiency, 1-bedroom and 2-bedroom apartments. And then the fourth and fifth floors were pretty similar. Again, a mix of studio, 1-bedroom and 2-bedroom apartments on a double loaded corridor. So we had almost a stacked plan, but not quite, which was a bit of a challenge when we were adapting it to mass timber. And before I go on, so all of the aspects of the project that I've described so far, so the program, the configuration, the location, the energy goals, those are all things that we considered control factors when we were going to go into the redesign. So those are all things that we did not change. What we did change are related to the construction assemblies. So the benchmark project was designed as a podium-style building. So it's podium plus 4, which basically means that we have a steel and concrete base that is non-combustible, type 1A, and then the upper 4 floors are all a combustible material. They're made out of light frame wood, and those are combustible. And because of the site constraints and the program requirements to accommodate the size of program that we had, we thought the most economical way to get tall enough was to have that concrete and steel base. And then we had a pretty simple bearing wall system, bearing walls on the front, the back, and the core of the building with the floor deck spanning between. So the wall assembly at the podium level uses light gauge metal stud framing. You can see here that there is a double stud wall, and again, that was to incorporate the amount of insulation that we thought we would need for the Passive House certification. And the metal stud walls were so that this was a non-combustible system. I'm also showing the brick-based masonry veneer, but that's consistent throughout the project. We didn't change the exterior look of the building. This is the wall system for the upper 4 floors. Same double stud wall, but here it's made of, I believe it was 2x6s or 2x8s, so typical wood frame construction. So this is the 3-hour floor assembly that separates the podium level from the upper 4 floor levels. We have a 5-inch concrete slab over metal deck supported by steel beams. And then above we have the finished floor, an acoustic mat, and a finished floor, plywood subfloor, and acoustic mat. And then we have a hung ceiling below for fireproofing and acoustic purposes. And then all of the upper floors were consisted of open wood trusses with a chipboard ceiling below and the same finished floor above. And the roof system, pretty similar with the open wood trusses and tapered insulation, all of the insulation with tapered on the exterior. So now on to the mass timber redesign. The major considerations that guided this were the exterior fire ratings, the acoustic ratings in the floors, and coordination of mechanical systems. So every choice that we made when we were redesigning the floor, roof, and wall assemblies, we made with these things in mind so that the final product would function the same way as it did for the owner, that the benchmark did, just in case that they did choose to go in this direction. For this redesign, we decided to go with a glulam post and beam structure spanned with 2 different types of timber decking, similar to what Ricky was talking about with, I believe, the T3 building. Our exterior wall system was a 1-hour non-bearing system. We used fire retardant treated light frame wood that wrapped the post and beam structure. So this was a type 3B building, which means that the exterior walls need to be built of non-combustible materials, but fire retardant treated wood is included in that definition. And then on the inside, we have a second wood stud furring wall that again is for this double stud wall and the amount of insulation. And you can see the glulam post in this image. At the second floor framing level, we use an NLT decking system over the glulam beams, and then we were able to expose that to the first floor spaces below. So all of those common spaces, you'd be able to see that beautiful NLT above. And we thought that was really important to include. And then above that, because acoustic concerns were really important to this particular owner, the Housing Trust, we have sheathing, an acoustic mat, and 3 inches of concrete above. On the upper floors, we had much shorter spans because of the layout of the apartment. So we switched from NLT to tongue and groove decking, about 2x6 tongue and groove decking. And then for here, we have a drop ceiling, which I'm going to talk about more later. But For this owner, we needed to conceal all of the mechanical equipment, and there, again, the acoustic concerns meant that we were dropping this hung ceiling. So unfortunately, on these floors, the upper floor, we were not able to see the underside of that timber decking. And then finally, the roof is the same solid sawn decking with the tapered insulation above. So like I said, part of this project was to identify what, if any, regional sources there are for mass timber in the Northeast. So Ricky's already shown a map, but here's one again showing what was sort of close to us. And while there's a lot of glulam manufacturers around the country, and there's Untitled in New York, there aren't as many CLT or NLT manufacturers close by, although it is pretty exciting that we have two proposed for Maine. At the time, though, when we were designing this, that was not true, or we didn't know about that yet. So we chose to incorporate NLT decking, in part because it was possible to fabricate on site or to prefabricate locally off-site. And then obviously solid sawn decking is something that was available around here. So those were considerations when we were trying to choose which mass timber system to go with for this project. So once we completed the drawings, we sent them to a professional cost estimator, the same one that had estimated the drawings for the benchmark project. And I've included a summary of the results here. So unfortunately, but not unexpectedly, the total cost of the mass timber design was about 10% higher than the benchmark design. There's a couple different reasons for this, but you know, it's not a huge gap, but it certainly is a gap if you're looking at hard costs only. So the major differences in cost were generally isolated to a few different divisions: metals, woods, finishes, and general conditions. So the cost differences in other divisions were fairly negligible, so I'm not going to talk about them here. The decrease in metals was obviously due to the elimination of that non-combustible podium on the first floor. So when we got rid of the podium, we got rid of all of the light gauge metal exterior walls and partition walls on the inside, and that metal deck at the second floor framing level. However, when we got rid of that, we replaced it all with light frame wood, with wood framing. So consequently, there was a pretty big jump in the wood division. So, and we also, so you can see that number is quite a bit higher, and that's because we might have removed the open web wood trusses, but we replaced them with the solid sawn decking and the NLT decking. We still had plywood sheathing for diaphragm purposes and for acoustic purposes, and then we added back all of those stick frame walls. And then there was also an increase in finishes, which did initially surprise us a bit. We thought that we might save on that because generally when you design a mass timber building, you have the opportunity to expose the mass timber, and therefore you don't have to pay for, you know, say in this case, gypsum board ceiling and painting and all of that. However, in this particular project, we did end up using a hung ceiling on 4 floors, so there really wasn't any savings here. And then finally, there was a decrease in the cost of general conditions. So mass timber can, like Ricky said, it can be constructed much faster than your conventional building systems. So we estimated that we could save approximately 3 weeks on the construction schedule here, which means that there is some savings in general conditions. And while it's not reflected in this number, I think it's also important to note that a shorter construction schedule means that you lease up your apartments faster and your rental spaces faster, and you have a shorter return on investment with the sooner occupancy of the building. So again, there's a 10% gap in shown here in cost, but it's not really looking at the whole big picture. So I think it was important to point out some of the lessons that we learned. There were a lot of different choices that we could have made throughout this process, and two that I identify here that I think, if we were to refine it more or maybe do this again, that we would change, have to do with the acoustic treatment of the building and also the structural grid. We had expected, like I said, a much larger savings in the cost of finishes because you can eliminate the gypsum and painting if you expose the mass timber to the floor below as a ceiling. And we did that on the first floor, but we sort of shied away from it on the upper floors. And at the time, we were trying to go with only like published tested assemblies. And I believe there was one instance where there was a tested assembly with 3 inches of concrete above. 2 inches of concrete would have done it too, but because that hadn't actually been tested, we didn't want to use that in case this project moved forward. It was important to the owner that we have those impact values, the STC and ICC, from a reliable source, I guess. And also, throughout this process, there's a lot of new materials that are being developed that came out every month. So there are other ways to handle the acoustic values. So I think if we were to do this again, we probably wouldn't have shied away from a different treatment of the acoustic separation, and we would have saved in the finishes division and exposed the ceilings above. And then the structural grid, we did not change the layout of the building when we decided to go with the post and beam structure, which meant that, if we had been starting this from day one, assuming that we were going with the post and beam structure, we probably would have laid out the spaces just slightly differently to optimize, the spans of the materials that we were using. So, in conclusion, in the reality of this study, the mass timber wasn't necessarily a cost-efficient substitute for light frame wood construction, but we should note that it has been used successfully for many projects across the country, like Ricky was pointing out. Just not so many low-rise multifamily projects. And we think this is because when a building design necessitates that you use steel and concrete because you have really long spans, much taller buildings, or restrictive fire requirements, then mass timber becomes a much more cost-efficient comparison if you're looking only at those hard costs. 29 Flat Street is a small enough project that it was feasible to do all stick framed, and therefore, it did come out as less expensive to do it just to build it stick framed only. But if we were to design an office building like T3 with an open floor plan, it probably would have been a more suitable comparison. And then there are also all of the qualitative benefits of mass timber that are that they add value for both the owner and the occupants, even though they don't show up in that cost comparison. So wood has a much lower embodied energy, and it reduces the carbon footprint of the building through carbon sequestration. And humans are instinctively attracted to natural wood. So a mass timber building can have a positive impact on the occupant health and well-being in the space. So those are both, added value to an owner that might decide to go with a mass timber building. So, the end product of this is that we did not proceed with mass timber for the 29 Flat Street building. However, we did decide to eliminate the podium, and we continued with a 5-story wood-framed building, type 3B. So that was an improvement.
Thanks, Jillian. And then we'll have Paul Frederick from the Vermont Department of Forest, Parks, and Rec.
Thanks, Ricky. As Ricky said, my name's Paul Frederick. I'm a wood utilization forester with the Department of Forest, Parks, and Recreation here in Vermont. And so my interest is really in markets for wood, and I work primarily with the forest products industry. Ricky and Jillian have made a great case for the use of mass timber. Some of the realities and the advantages, but I'm kind of left with the final question here, and that's, so what's in it for us? How can we make this work for the forest in Vermont? And how can we carve out a niche for Vermont's wood products and the products of our forest through the use of mass timber? So what I'm going to talk about this morning quickly is, why should we even consider Vermont wood in these projects, and what's available, and then how can we use the wood that we do have available in mass timber designs. So just to give you a little background for those folks that aren't foresters in the audience, we have about 4.5 million acres of timberland in the state. People have mentioned this morning, somewhere between probably 75 and 80% forested. Timberland is essentially defined as land that's available and capable of growing a crop of timber on it. And on that land, we're growing about two times as much wood annually as we're harvesting or as is dying. So it was mentioned this morning, I think Katie mentioned this morning, that overall on a nationwide basis, we're actually going into negative growth numbers. But that's definitely not the case in Vermont, and we have an opportunity to utilize more wood in new uses and still have a very sustainable system. Of that land in the 4.5 million acres, about 80% of it's privately owned. So one of the things that we're really concerned with, and it was mentioned again this morning with respect to the current use program, that we have 87,000 landowners out there in the state paying taxes on this land, and it's a constant output of cash to maintain it, keep it in forestry. So anything we can do to ensure that there's a periodic income from that property so that landowners are at least in part compensated for the keeping that land open and keeping that land forested is a good thing as far as we're concerned. So what is it that we do have available? If you look out the window, you can see that primarily our forest in the state of Vermont is a hardwood forest. About 71% of the forest land in the state is made up of cover types that are based on beech, birch, and sugar maple. So primarily hardwood. If you look at the graphic and the list here, you can see that this is a list of species abundance based on standing saw timber volume, and it's in descending order. So sugar maple is by far our most abundant species, followed by white pine and hemlock. And if you go way down to the bottom of the list, number 8 is red spruce. And it's important to note that where red spruce falls out in the mix, because spruce is the species that's most commonly used in structural applications in the Northeast. It's the species that we have that's most likely to end up in a structural application. So what's growing is part of the equation. The other part of the equation is what do we have the mill capacity to process in the state. And these two maps basically just show where our larger active white pine and hardwood sawmills are in the state. Scattered around, the white pine mills scattered around, but primarily in the Champlain Valley and the Connecticut River Valley, where we have more of a concentration of pine, more of a general distribution of hardwood mills, though there's not much north of Route 4 actually, and certainly not much north of Route 2, and a lot of that's a result of the fact that there are a large number of hardwood and softwood mills between the Canadian border and the St. Lawrence River. So there's a number of mills that are just over the border in Canada that we ship a lot of wood to. The other, so going back to the spruce fir, so we have capacity for milling white pine, we have capacity for milling hardwood, and there's a certain amount of capacity for milling spruce and fir, but it's really in small local sawmills where that material is being used for framing lumber. Oftentimes it's sold green, and it's primarily for local uses. Generally not structurally graded material. And the map on the right here kind of shows you where the structurally graded material is being produced in New England and in the Northeast. Primarily Maine and Quebec. There's one mill in northern Vermont, Sear Lumber in Milton, that can do some hemlock grading, but they do very, very little of it. And a mill in Milan, New Hampshire that also produces structurally graded spruce lumber. So we don't have the capacity in the state to really process spruce fir. We don't really have an opportunity to put out that structurally graded material. So that sort of limits the uses, or limits a big piece of what goes into CLT and some of the other mass timber products, because structurally graded material is needed for those, to make those products. So we may not be producing the wall panels, the floor panels for those applications, but there are some other applications where we could use some of our native material. And that's really in non-structural applications. Jillian pointed out a number of places, I think, in the building that they were considering in Brattleboro, where there were opportunities for using non-structurally graded material as part of that whole system. Ricky mentioned the UMass design building and the fact that it's really a hybrid system. There's it was some CLT and mass timber components, but there were other components that were of other systems. And this is an example of that. This is non-structural wood being used to cover some of the structural steel components. There were steel I-beams used in this building that they basically covered with wood to make them look more appealing, and basically that material doesn't have to be structurally graded. Another potential use, and Jillian mentioned the drop ceilings in the building that was designed in Brattleboro. You can use non-structurally graded wood in those ceiling designs. In this case, the fellow on the lower right installing wooden panels, that same application can be used with lumber or glued up panels. And basically the drop ceiling gives you the opportunity to cover up those mechanical, electrical, and plumbing systems that you may not want to see in the building. I threw in another slide that just showed some different species, different grades being used as ceiling material in. And these aren't necessarily in mass timber buildings, but it kind of gives you a sense for the variety of effects that you could get by using different species or different grades of lumber in those sorts of non-structural applications. A couple other examples. This is a community college building in Oregon, and non-structural wood used as soffits and as siding in this application. And another fairly similar application, this is a farmer's market in Virginia, and again, non-structural wood in the soffits and in the cladding on the walls. And then finally, Jillian mentioned some of the hybrid floor systems that utilize mass timber and concrete. Well, you don't necessarily have to make the concrete the walking surface in those applications. There could be possibility of using wood flooring in some of those buildings as well. So just a couple things to keep in mind, and then we'll wrap it up and take questions of the panel, I guess. Look for the opportunities to utilize those local species in non-structural operation and non-structural applications in these buildings. If you're specifying, it's important to specify species that are at least native to Vermont or the Northeast. Oftentimes we see buildings, and we had an example of that in state government, where a new building that was built in Waterbury after the flood during Irene, that building was specced with a lot of wood, but it was all specced with yellow poplar, which you can probably find it in Massachusetts, but you certainly aren't going to find it in northern New England. And it's just a matter of making folks aware of what it is that's available and what it looks like, and how our native species can be used. And then finally, if folks need additional information, help in finding suppliers, myself, I'm available. Christine McGowan does a lot of this work with individual companies, and we'd be happy to help folks find suppliers and investigate species that might work for their projects. So, thank you.
We've got about 20 minutes for questions. So answer several questions. I guess the first one would be, what on that cost for the CLT that you had in the estimate, how much of that was shipping?
I can't tell you exactly how much of it was for shipping, but I can tell you that our cost estimator, the product that he spec'd was out of Canada, out of the Northwest.
Shabukamu?
I think it's structure land, I believe.
Oh, well, on the Western Canada.
Western Canada, sorry, yeah.
So we don't really know how bad that price was. It could have been considerably lower.
Off the top of my head, no, I don't know, but a lot of it was shipping, and that's because currently there wasn't a closer place to get it from.
So, I'm thinking you're not going to have to preach much longer to the choir out here about using wood for this. I think what we want to know is, when can we get a CLT plant in Vermont? Is there just out of curiosity, a primer on what acreage, utilities, a typical CLT plant builder would want to see for a CLT plant in Vermont, so that maybe there could be some marketing by people like MBDA to see if they could attract somebody up here to the Northeast Kingdom to have a plant like that, or somewhere in Vermont? Because, I mean, if we're producing this stuff here, New York City's not that far, as is Boston, and we've got the wood. Well, no, that's my next question. Why are we limited to spruce? I mean, I'm just curious.
I'm not sure we are limited to spruce, but we're limited to structurally graded lumber. Right.
Okay.
And that's the species that we have the most of that would be typically would be structurally graded.
So if we're getting a few more people trained in that, it's conceivable we could be using pine and hemlock, or even hardwoods. I would suspect primarily you're into the softwoods, right?
Yeah, there's a lot going on currently in that, looking into, for example, at UMass, the building at UMass, they're actually doing testing on different species on CLT in that building. Hemlock is one of the species that they're looking at now. And one of the nice things, I kind of alluded to it in Blue Land, one of the nice things that's the same for CLT is you can vary from one layer to the next what grade of wood you're using. So, is it potentially using a spruce fir mix from Maine for the top and bottom laminations, and a hemlock mix from Vermont for the middle laminations? There's a lot of different possibilities using hardwood just as maybe you do a 4-ply panel, and the bottom layer is hardwood from Vermont, and the other 3 are spruce fir of that market opportunity in the future. As far as
pine?
I'm sorry?
How about pine?
Pine is a possibility. It all comes back to structural properties. You know, when you look at white pine versus spruce fir mix, the structural properties are lower.
Right,
That's not to
but
say-
they're not significantly lower. I mean, it would be a matter of making the panel potentially thicker.
That would be one possibility.
I mean, yes, there are several limitations, but structurally, it's a little more brittle, but I don't think there's that, it's a small percentage delta there between spruce and pine.
Yeah, and part of the problem is that because mass timber is so new, you're generally trying to convert, if you want to use that word, somebody who's used to doing steel and concrete, so they don't want to see columns at 16 feet on center, they want to see columns at 28 feet on center, you know, whatever the difference is. So just getting them the education that they need to understand, is there a difference in my column spacing? Why is there a difference in that? That may sound like a trivial thing, but for developers in particular, it's a big hurdle to get over. So it's kind of a combination of how far can it span and back to what species is it using. But yeah, I certainly think that there's opportunity to incorporate Vermont grown, whether it's softwoods or hardwoods, or even, you know, some of the other workforce things that, you know, like getting more, there's potential for some manufacturers of just producing blank CLT panels. Maybe that's not done in the state, but maybe in the state we come up with a company that's just taking blank CLT panels and then they're buying those and they're kind of doctoring them up themselves. And there's an organization in New Hampshire that's doing that right now for project-specific applications, or even blue land, CLT. So I think that's another opportunity for Vermont manufacturing side.
So if we can grow this whole market, there might be an opportunity to see plants that would be able to use other products here besides spruce fir.
Yeah, the other comment I'll make, I'm from Maine, and we've attracted 2 CLT plants. They want to co-locate with a sawmill if at all possible, or certainly be as close. So typically a CLT doesn't want to be a standalone because there's all that added as you bring up transportation costs. So the way to attract CLT is to have a sawmill either right on the site or very close to that. So that's an important consideration as well.
That could be right across the border then. I mean, there are a lot of softwood sawmills right across the border.
So I have another question that's sort of in the same as the marketing, more towards Paul, is that in her case, there was a significant difference in cost, 10% or things like that. Other places, they usually have incentives for these people to choose the wood products to be able to promote wood, things like that. Is there any government type incentives or anything like that in Vermont that are going on to help the marketing?
Not that I'm aware of. Not that sort of incentive that I'm aware of.
Was there any carbon equation in the cost differential?
So our project, because it was only the conceptual design, which is the very first phase, we didn't go into enough detail. Woodworks does have a carbon calculator, so I think if we were to develop it further, we could do that, and that's something where, when we were sitting down with the advisory committee, we talked about, like, what if there was some sort of an incentive for the carbon, and that would make this a more significant comparison.
Because I think that's one of our large arguments in wood frame building is the carbon storage component, becoming obviously much more evident. And, we see this in the whole discussion of steel, concrete versus wood. The carbon footprint is so much smaller, the sustainability issue. So it seems to me that that's something we need to be working on is from a planning. If you're going to have building codes, tying into environmental codes, where, if your carbon footprint is lower, there's a long-term cost. And you did mention, I was curious about energy use. Was the new building going to have a less energy use, or did you get to that point of calculation?
We didn't get to that. We were just trying to accommodate the same amount of, the R value of the floor and the roof and the walls, so that it conceptually would be the same. Although we didn't, wood does have an insulating value, so for the roof, that would be something to consider, and that would add to it. Maybe that means less insulation, take a frigid insulation.
Yeah, an interesting addition to that comment is that the UMass building that several of us showed, because of the inherent insulated values of wood, so for example, in particular, the roof system there was cross-insulated to the roof panels. They really didn't take that into account in their energy assumed that that was providing no insulative value, and the insulation on top that they placed, they were using that as their baseline. But CLT, it was about, I think, a 9.5-inch thick panel for the roof. CLT has about an R value of 1.25 per inch of thickness. And that's over an R of 12 plus that they were achieving just through that CLT panel. And that was in addition to the insulation on top. So that particular building, I can't remember the number off the top of my head, but it's seeing significantly lower energy use than they anticipated. And they designed it for a significantly lower energy use than the code requires. So from what I've heard, that's performing very well.
And I have to add that actually, even with the building that we did continue with, the fact that we got rid of that steel podium does mean that we're performing better because steel studs have a terrible R value.
Steel is just basically terrible. Let's just all agree on that.
This is for Paul. There was a previous conversation before this that I had with the other gentleman about getting V-Trans to build more wooden bridges. The Forest Service has had a manual out for that for 70 years, where you're using glue lam or just heavy timber for the decking of bridges. The drawback in my eyes would not only be the fact that I don't think there are any glue lam plants here in the east, but do we have facilities in the northeast for treating heavy timber or glue lam so that they could be building bridges out of wood?
The only facility that I'm aware of, and I'm not sure if they're still in existence or not, is Maine Wood Treaters. And are they still viable? So that's the facility that I'm.
Where's that? Oh my God. So
Not very far. In our standard.
no,
No, it's not bad.
But that's potentially the only treatment facility in New England.
That's the only one I'm aware of.
So we've got all of this great timber in Vermont, and we have to ship it up there to get it treated before we can build a bridge here in Vermont.
Yeah, and we've actually done that some with state lands timber, with bridges on state lands where we've purchased local timber and shipped it to Maine to have it treated previously. But yeah, that's as far as I'm aware, that's the only one.
And all which I would consider New England smaller than some western states. So you just don't think about crossing state lines and the distances get close.
So if you can't get Kia from there, you're not there either.
I have a question, Jillian. Would you consider the project again, given the rationale of steel going on in the current environment?
We did actually, and even with so this project is a real project that's ongoing, and we're working with the construction manager. And there was the thought that we actually had him estimate this as a full steel stud building all the way, all 5 floors, and that came back as more expensive. Which is, so we tried that avenue and we stuck with wood frame because it was the better option and the cheaper option.
And then one other question, I just have to ask, has there ever been any more projects, maybe not like gearing, but maybe incline or something, but it seems like it's a little bit more costly to do.
Out of Mass Timber?
Yeah, or better.
Yeah, so actually, Casey Malmquist, who owns Smartland, who's a CLT manufacturer in Montana, and also one of the 2 that have announced plans to open in Maine. So they plan to open a second facility in Maine. He, I believe on his own personal property, constructed a CLT, I believe it's an equestrian, can't remember the exact square footage, but yes, I mean, that's just one example. I'm sure that there are others, but off the top of my head, that's one example.
The example that Ricky showed of the timber frame company in New York State, I actually had an opportunity to go through that building after it was completed, and it would make a great riding ring. It's a big 3-span building that they're using as warehouse space essentially, but it's pretty roomy.
Back there?
What does Vermont's private sector in timber and forest products need to enter into this, relatively new sector, whether it's panel construction or the assembly of the buildings? I mean, what's that big ticket need that the collective of the private sector would need? not a spot, so maybe there's something to think
Well,
about.
I would say on the manufacturing side of things, it would go back to what we talked previously about getting, Vermont-grown species, whether it's softwoods or hardwoods, getting that more either widely accepted or recognized in terms of the structural properties and their use in the production of mass timber products. So whether that's, using hemlock or maple or something like that, getting the research, the testing side of things that has to happen in order to get it more mainstream, that's probably one of the larger hurdles, I would say, in the manufacturing side of things. On the more of the, I think the other side of your question is like the construction side. I think that Vermont is actually suited very well in the sense that, we're probably more so than most other states have a large volume of timber framers, at least, compared to other states. And mass timber is unique in that there's always this question, well, who's best suited to install it when nobody has experience? Is it more similar to steel construction, or is it more similar to traditional wood framing? And it kind of falls in between, and I think where Vermont has the advantage is that it's somewhat similar to timber frame construction. It's using large cross sections, like steel erectors are very familiar with those details, whereas a carpenter may not be. So I think that using the timber framers that we have in the state, leverage their knowledge of working with large timber cross sections, and go through a process of training them. We're actually working on right now what we're calling an installer training program, where we're going to be in the next 18 months or so going around the country using people that have installed mass timber products on buildings and training local workforces to be able to be essentially certified to install these products. Because not only do you have to have people that are willing to design it and understand how to design it, you also have to have people that know how to install it, know how to estimate it. One of the hurdles that we see a lot in mass timber buildings is they don't get beyond the cost estimation phase because people don't necessarily fully understand what it is. So because of that, they always place a contingency on it. That contingency, of course, raises the price, and when it gets down to dollars and cents, people see that, mass timber is more expensive, I can't use it. My owner's not going to allow me to use it. So if we can start to get things like the acoustics that Jillian mentioned down, cost for those products down, get the installer's understanding of things down, lower those side costs, then I think eventually we are going to see much more mass timber construction. I think obviously all of us here recognize, and much of the design community recognizes, the advantages of wood construction. We can pair the advantages with cost feasibility, then I think it's only a short matter of time before it becomes much more mainstream. Any other questions? We've got 6 minutes. We can just sit here for 6 minutes.
Do you see the future of this, that once we kind of do the research and get ahead of this game, figure out, we was talking about maybe they could have done this and not spend as much money on certain things, that this is going to kind of take off. Is that your feeling?
Yeah. Obviously I'm biased, as most of us are.
Right, but I want my honest opinion.
The
direction the research is going, that was going to...
Yeah, even just...
That I stock today.
Well, if you look at Europe, they're way far ahead of us on wood use.
Yeah.
So it's not that this is unique.
Right.
So just I think the point that you were making, Richard, is that getting the system to understand wood construction and accept it is really the stumbling block at this point.
Yeah, the short timeline that I've shown the CLT has, there are over 500 CLT buildings that you know right now. And, just to look at how far they've come in that short amount of time. And then in the U.S., it's been 10, maybe 10 and a half years since the first CLT project that we built in the United States. Now look at where we are with what the code allows, where we are with all the building code changes that we're looking at, and even the number of CLT projects being built every year is ever increasing. So I think it's going to be a combination of lowering those costs, like I mentioned, getting people to recognize what it is, it's just a lot of people don't even know what mass timber is. So widespread recognition, which I think is why something like a demonstration project, our Vermont Mass Timber Action Team has really been trying to find a demonstration project in the state. Even the UMass building in Massachusetts, it's funny, you talk to people in Boston, and they're they're like, yeah, but that's out in Maine first, you know. They don't even recognize that within their own state, there's this great resource. So I think getting something that people in the state of Vermont can go to and say, this is a local mass timber project, understand it, see it. I think there's a connection there that really takes place. So it's going to be a combination of those things. But yeah, my honest opinion is absolutely, we'll see a great increase in this in the next 5 years.
Ricky, can I just comment? I mean, I think it's worth being bullish about. I think we do need to acknowledge, though, that, I mean, the steel and concrete lobby is not real keen on this. I mean, there have been some legislative attempts, something called the Timber Innovation Act in the last year, which has moved forward, but it was really striking and not in a great way to see how those sectors mobilized against it. So I think that's part of the work here, as well as building, you know, some of that political will to create some of those incentives and overcome that. Because I do think it has great potential, but I think we need to recognize that there is a strongly entrenched set of sectors out there who have a lot of political capital and a lot of money who are, you know, sort of fomenting, I mean, one ad was, is it time to rethink wood, and a picture of a clear cut. So there is that type of stuff out there that I think all of us who are interested in this, it behooves us to be, again, voices in the choir talking about the benefit to anyone who will listen to try and overcome some of that.
Maybe pictures of open pit iron ore mines might help.
Yeah.
Yeah, it's a great point. And I will say that there are incentives. Somebody asked the question about incentives in Vermont. There are incentives in several other states, and I've had some conversations with Vermont-based legislation as well. But like the state of Washington, state of Oregon, both have bills that have been passed that are, whether they're financially incentivizing or just at least, you know, pledging the state's support for mass timber construction. Also, California very recently, within the past 2 months, I believe, passed a bill that is promoting the use of mass timber projects, but also in particular manufacturing they're looking at there. They don't want to have, even something as close as Oregon or Washington, California, they don't want to have to pull in mass timber from there. They want their own manufacturing facilities. So I think we're seeing more of that as well. Even the state of Maine, last year put a bill in that eventually died. Part of the reason for that was because of how bullish they were. They're basically saying if it's a state project, it has to be mass timber. So there's probably some more sensitive ways to go about requesting something like that. But yeah, I think there's definitely going to be continued action on the state level for promotion of that. And especially, I mean, I think it's so significant that the governor was here this morning getting the state behind this movement and the impact that it has on the economy.
At the federal level, the Forest Service has been very supportive and put a lot of money into this program. And you know, they have a Wood Innovations Grant process that they go through annually. And this year there was a litany of projects that involved CLT that were funded through that program. So there, you know, on the federal level, there's definitely a lot of interest in the Forest Service. So.
Thank you all for your time. I believe it's lunchtime now. Thank you.